I call this how I failed to automate myself out of a job. So yeah, I'm kind of hoping that I can take you through how I got to where I am today. Yeah, how this sort of thing with network automation got started for me. So who am I? So I'm supposed to be a software engineer these days. I'm not quite sure what that means. But yeah, I started out as a network engineer, and gradually started like automating things, and yeah, and kind of got to where I am today. I break things a lot. I'm pretty lazy, and I'm not really good at repetitive tasks. So yeah, if you give me something that means I have to press the button about 20 times, then yeah, by about the 5th time, I'm probably going to see a squirrel, and yeah, just lose track. I'm also a Linux enthusiast. I'm running stuff like Pi-hole, yeah, run a lot of CentOS boxes for fun. Got a little web app running out there. If anyone wants to try it, yeah, let me know. It's pretty niche, but yeah, maybe you want to use it. Okay, so my part on this network automation journey started a long time ago on a end-of-life refresh project, and you know, like all great projects, it starts with someone coming up to you and saying, hey, there's this spreadsheet on SharePoint, go there, look at it, there's a bunch of stuff you have to do, figure out whether you need to replace these devices. So you have like a bunch of host names, some IP addresses, maybe a few additional details. So yeah, basically not really a lot of information, and yeah, you kind of just have to get on with it, really. So what I found out was that my predecessor, what he told me was, what you need to do is copy each one of these IP addresses line by line and ping them. If they're alive, that means they're probably out there somewhere. Then you need to figure out how to get onto these devices, and then yeah, then you can get on with replacing them. So I thought to myself, there must be a better way. And yeah, I kind of looked around and thought, okay, what tools have I got? We didn't really have any IPAM. I didn't really have like my access to root or whatever was still coming through. But there was a jump host, but no root access, so it was sort of like locked down enough so that you could send ICMP outbound, but that's pretty much it. I'm not quite sure why people won't give you root access to a sandbox server, but you know, they'll give you access to bring the actual business down to its knees. But yeah, you can't install drivers on your laptop, and yeah, you can't be root. So yeah, great. So with this in mind, I wrote something, yeah, you know, my first bash script. I don't want to say that it was my first thing. I've blindly run bash scripts several times before that I've downloaded off the internet, not in prod. So yeah, I kind of came up with something like this. So if you've used Linux before, this is pretty simple. Like for those of you who don't, it's the first, well, between the pipes, if you look at what's happening there, that's what's going on really. So I have a CSV file, I output that to awk, which prints the first column in it, which is most likely your IP address. Then I supply that to the ping command with a count of 1, and I grab the word from the output, which, if it's successful, should tell me that your device is actually living and is around. So yeah, so when you think about 100 devices, how long is it going to take you to go line by line, copy, paste, do that over and repeat 100 times? For someone like me, probably it'll take me about an hour, maybe an hour and a half. Maybe someone comes around and goes, hey, did you see football yesterday? And you're like, yeah, it was great. And then you forget where you were, and you have to start again. So from about 2 hours, I reckon, I kind of went down to about maybe a minute, a couple of minutes, and I thought, oh great, right, you know, it's 2 hours, I've saved 2 hours, that means I get to go home 2 hours early. So unfortunately, no good task goes unpunished, so I got put on another refresh project. So this time I was a lot more lazy by this point, so I thought, you know what, like, start copying and pasting things onto these devices. Let me see whether I can like actually generate a config and push them onto them. By this point, I think Bash wasn't really the tool for the job, so I started learning a little bit of Python, did some config generation. I think most of you who work with network automation have probably played with Netmiko, Napalm, maybe like Paramico, that sort of thing before. Yeah, I see a few people nodding their heads, yeah. Yeah, great. So yeah, so I did that. And I thought, yeah, this network automation stuff, it's great. It's pretty simple, you know, so let's get out there, do something a little bit more challenging. At this point, I joined an MSP stroke colo provider, so they had massive scale. So previously I used to work in the enterprise, and in an enterprise it's not unheard of for like maybe replacing 2 firewalls is a large project, like maybe they're like front-end facing, like web facing, whatever, and then that's a large project in the enterprise space, right? In maybe colo MSP space, that's probably what you do before you sit down for your morning cup of coffee. So yeah, so it wasn't unheard of for you to have maybe 20 devices that you have to upgrade. All these devices are probably taking a full table from the internet. So your pre-post checks, for 20 devices, you've got to make sure all your neighbors are present. You need to make sure that your TCAM entries are okay before and afterwards. So you don't really have time in a 3-hour window to go around upgrading some software, having enough buffer time in case something goes wrong. I mean, how many of you have reloaded a device and found a line card not come up? Nobody? Yeah. Yeah, there you go. Right. So yeah, if this happens, your maintenance window is pretty much done. But on the good side, because you have scale like this, it allows you to automate a few things. So I wasn't very good at kind of going through stuff and kind of inspecting it and making sure that this was there before. I don't remember if it should be there after the maintenance. So just if you've got these repetitive tasks, you can just automate it. You don't need to check 20 devices for the BGP neighbors. Fine, you can automate that. You want to check whether thousands of TCAM entries are present across all your devices before and after your maintenance. You can automate that. That's fine. So around about this time, everything was going well, but I still had a few annoying tasks that I wanted to automate my way out of, and I think the worst one, the one that I always hated doing, was converting software from one vendor to another. So you've probably been there. You probably had to swap an ASAP for an A10 or maybe another vendor's kit. So it's like usually how the process goes is you have version of software X, vendor Y that you want to go to whatever. There's some syntactical changes, so you artisanally handcraft maybe your NAT entries, maybe your server farms, that sort of thing. Like a lot of things go wrong. So I thought, this seems like a tedious process that can be automated. So I wrote this tool that would handle your conversions for you. And this was probably like the most amount of code I'd ever written at that point. So I was like super proud of it, and I was like, hey, look, everyone, like I made this thing. It's awesome. So a lot of people where I worked were having the same problem. So they were like, okay, all right, we want to use this tool too. So I thought, okay, this is great. Like I've got users now, customers maybe. So I built this like a little web front end for it. So you could just go supply it with your host name that you want to convert from A to B, and it would dump configuration out for you. If you were really brave, it would try and push that configuration out to another box for you. Not many people took me up on that. But yeah, so this is great, right? So I've got users now, customers, this is great. But unfortunately, this was a bad thing. Has anyone written a tool for someone else and put it out there for public consumption? Yeah. You probably know why this is a bad thing, right? This is a big mistake. Once you have users, what do you have? Yeah, exactly. You have problems. You now have to maintain your code. You now have to field feature requests. You now have to deal with bugs as they come along. So if you don't really know what you're doing, like if you're something like a sole coder in a team, then you probably do some pretty horrible things along the way, right? So this is a list of some of the things I did. This is great. I think I'm pretty sure some of us have done this before. So who's tried to find IP addresses by splitting on periods? Anyone? Yeah. Okay. Yeah. Okay. That's cool. Brave of you to admit to that. Yeah. I did that. I passed credentials in plain text. Use stuff like continue, break statements. It's great. I love break statements, but I still don't. On a good day, I'd probably understand how to use them as well. I never wrote unit tests, but not a real one anyway. I probably looked at something. There was probably something that I grabbed for some strings that made sure that I didn't cut myself off the device, but that was probably it. I didn't document my code very well. I think. Does anyone here use PDB for debugging? Okay. All right. Got some professionals here. Okay. Who uses print for debugging? Hey, more like it. So anyway, for a laugh, I put some of my old code through a linter, and none of them got a positive score. That minus 1.69 you see there, that is the best I did. So yeah, go me, right? So anyway, I thought, okay, there must be a better way. So by this point, I was a bit burnt out being like the only guy who wrote code who maintained his, who had to maintain this thing. And I thought, let's go see how the professionals do it. So in 2016, I went to PyCon, I had my first code review. It was a depressing experience. Yeah. But on the plus side, it did kind of reinforce to me that this is what I want to do more of, right? I want to write more code in day job. I want to do all these cool things, like people are talking about data science, and I don't know what, like infrastructure as code. I was like, yeah, whatever, okay, cool. Let's see, is anyone, so okay, let's see if anyone actually is doing this out there, right? So I met Andree at this point. I was like, yeah, we're doing all this stuff, APIs, yeah, we're doing that, config management, yeah, we're doing that, event-driven automation, yeah, we're doing that. So I was like, yeah, okay, cool. And then I kind of like got a little bit of a deeper look into what they were doing, and it was incredible, right? So, like this blew my mind, right? Like, so up to now, like automation was this thing that I'd heard about on podcasts. It was something that early companies who have, Jesse Eisenberg as the leading star in a movie were doing, that sort of thing. So yeah, I was like, this is great. Like these guys have automated all these things, right? And I'm really lazy. So all I need to do is, first day, I'm gonna turn up. I just put my feet up, like find out where the coffee is, find out where the biscuits are maybe. And because I get to work from home a lot, I already know where both those things are, so it's even easier. And I thought, yeah, this is going to be super easy. This is going to be a really sweet gig. But I was hugely mistaken. I think in the year plus, maybe like roughly 16 months since I've joined there, I'd be hard pushed to tell you a week where I haven't learned something new. Like first of all, you have to learn a lot about cloud-based services. I think we're writing like APIs, like we're working with APIs pretty much daily. We do stuff like TDD, writing unit tests, we do event-driven automation. I think some people are already talking about extracting some of the things that we use into microservices. So like these are basically like things that a year ago I did not think this would be something that I would be doing. But yeah, it's pretty great. Like, I guess the takeaway that I'm hoping that people will get from this is just because you automate away a bunch of things doesn't really mean that you're going to be replaced or that you're replaceable. It just means that the problems that you have to solve just become different. Yeah, you learn a lot more, like you're going to be out of your comfort zone quite a lot, but I guess like that's the point where most of your growth happens, right? So yeah, I guess I'm trying to say that it's nicer to have a frustrating problem that you can solve in an interesting way than a frustrating problem that you can solve, but is super repetitive and super boring. But yeah, and on the plus side, I actually went to PyCon the next year for I went to PyCon the next year and showed some of my code, had another code review, and they were like, oh, so how long have you been a developer? And I was like, oh, that's great. I'm not really a developer, but yeah, like I say, it just took me like 3 years of faking it until I made it, so awesome. All right, so with that, I'm gonna hand over to Andree, and yeah, he's gonna give you a bit more of an in-depth look into what we do.
Awesome. So Dhana is now graduated to an actual software engineer, and so Dhana is one of our rockstar engineers. So my name is Andree. I manage a software network engineering team at OpenDNS, Cisco, and we're sort of responsible for a lot of the Cisco Cloud Infrastructure. Most of this came out of the OpenDNS acquisition, and now Cisco's investing that to kind of making that their cloud infrastructure. And some of you might also know me from BGPMon. I developed a service called BGPMon.net. But today, I want to talk a little about one of the examples that we've kind of automated ourselves out of a job and figured now we are done and actually we're not done. But the cool thing is, now that we've got that part out of the way, we can actually focus on some other stuff that is really cool and adds value to the business. And we can actually redesign this network now because we have time. And so one of the big problems for us was transit maintenance. And so we developed this tool called Transit Terminator. So first off, just a real quick introduction to give you an idea of kind of what it looks like, what we're responsible for, what Dhana's responsible for, and the rest of his team. So lots of DNS queries, 145 billion a day, that's about 2 to 3 million per second. 90 million users use us every day. And that comes with a pretty big responsibility. You don't want to go down. If your DNS doesn't work, nothing works. So we try to make sure that doesn't happen. Lots of facilities around the world to make sure that all works. And with that, lots of peering sessions and hundreds of network devices and over 100 what we call transit connections, so ISP connections, right? Links with other ISPs. So all of this needs to be automated because either we hire 100 network engineers or we hire a few smart people like Dhana, right? And so we kind of opted for the last option. And it worked out quite well. So we talk about 100 transit connections or over 100. So if you just run them off, every day a certain percentage of those sessions will underperform. And here you can see a random example. We measure packet loss and latency. You can see, for maybe an hour or so, this connection was basically useless. 60% packet loss, or 40, whatever it is. It's not usable, especially if you use DNS or gaming or whatever. You can't rely on this. So there's lots of reasons for that, but just like many other people, we're always under attack. This is an example of an attack from a few years ago. 2 of our IP addresses are under attack. This is one, the other one was happening at the same time. That's like 38 million packets per second. That's a few hundred gigs. That can cause, in certain cases, congestion and packet loss and so on and so forth. So for us, that meant lots of pages and lots of waking up in the middle of the night and never actually get to finish the project that we wanted to finish. So the remediation of these problems was always the same. This ISP is bad. Let's figure out which ISP it is. Shut it down. Act PagerDuty and go back to that. But there you already have it. It's always the same. So it's repetitive. We can write playbooks for it. And sometimes people say maybe we should hire a tier 1 engineer or outsource it to wherever. And I'm like, well, if we can document it, we can probably automate it as well. And sort of that's the road we went down on. So the team started over time developing all these APIs, just APIs specific to the network. So we can get a list of all the locations, and all the locations list all the devices, and then loop through that and get a list of all the ISP connections. And then there's a checks endpoint that will tell me the health of each of these connections. And so now you can start to see how you can now start to program against your infrastructure and at least get all the information and maybe even program against it and change certain settings. So these are the kinds of APIs that Dhana was talking about. And so one of the big things in our team as well is like when something goes bad, we want to be the first one to know. So we talk about 2 types of customers. We have our internal customers, the other server teams, SRE teams, and so on and so forth, and then obviously the public customers. And in the early days, we often got woken up in the middle of the night by one of my coworkers, and he would be saying, all the log files are stuck on the servers in, say, Singapore. And I would go in and do trace routes and figure out which one it was and shut it down. It wasn't that one because it was asymmetric. And half an hour later, I figured out, I think it's done now, and then the problem had magically gone away, right? So that's very frustrating, and so we decided to change that. We should be able to know exactly what the state of our infrastructure is at any point in time, and not rely on other people to tell us that it's broken, because that's very hard to argue with. So we started developing these tools, and one of these tools is it measures full mesh, the latency and packet loss between all of our locations over all of our ISPs. So these are like thousands of measurements every minute. That we get, and you can just use on Cisco something like IPSLA or Juniper or RPM checks. We fetch them every minute, store them in a database or some kind of time series database, and then you can start to evaluate these results. And you can visualize them, send them to other teams that always blame the network. Well, now you can say, hey, it's all great, it's not the network, go away, right? Or if you do believe it is, at least you need to come up with some proof. Right? I don't want to always prove the negative. So what you also can see here is in that little mouse over the graph there, you can see a little spike of packet loss up to 60% between, in this example, Chicago and Palo Alto. And you can see it only lasted for 1 to 2 minutes. So I want to talk a little bit about what that is, because that's actually some of this software at work automatically rerouting around the packet loss. So if we take a look at this example, you have at the top data center in San Jose, at the bottom London, and we have 3 providers, for example, in the middle. We don't have a backbone or anything, we just use VPN networks to do that. We have 3 providers, San Jose, London, and between the 3 providers, in this particular example, level 3 has the best connectivity, so the lowest loss and the lowest latency. And at the same time, you see what's called a transit optimizer. And that's basically a piece of software that every minute evaluates between San Jose and London what is the best path. And it figures out that maybe it was level 3, okay. And then it instructs these routers, so it has BGP sessions with all the routers around our infrastructure, iBGP, saying, hey, if you want to go to London, which is this prefix, set your next hop to this. And with iBGP, you can control the next hop, and this is essentially how we can reroute around packet loss. And we change these next hops every minute, depending on if there's packet loss. And that's typically why, if there is loss, it only lasts for 1 to 2 minutes until the software kicks in, detects the loss, and has the ability to calculate another path. And this has been tremendous for our internal teams. It really helps us route around packet loss. There's no more pages for the other teams. So even if there's an issue in the region, at least we made it invisible for the internal teams, and we can deal with it, but the pressure is kind of off. That only helps us, like the internal teams. It doesn't really control how traffic comes in from the actual customers to us. So there's another tool for that, that's called the Transit Terminator. So here you see an example of Telstra in Sydney. Lots of our other facilities are seeing packet loss over that provider. At this point, the session is better off down than it's up. It's doing more harm than good. So the Transit Terminator goes in, terminates it. It does a whole lot of safety checks, because we don't want the software to go on wild and just randomly shut down. And I can tell you there's been many, many meetings about what is acceptable, and a lot of discussions with my director, and making sure that he's comfortable with this. But we all recognize that if we want to automate really ourselves away and don't deal with these mundane, repetitive tasks, these are some of the risks that we need to take, and we need to invest in having the right controls around that. So in this case, an hour and 10 minutes later, software continued to monitor it, figured it's healthy again, it's been cleaned for the last 10 minutes, and brings it back up. So this particular piece of software kicks in about 5 to 6 times a day. So, and these used to be 5 to 6 pages a day, whether it's weekend, middle of the night, doesn't matter. So it's our best friend. So this is just one example of how network automation helped us. We have a bunch of initiatives going. This is probably about 1 in 5. So we have 4 or 5 other interesting ones that we'd love to chat with you about if you're interested. Yeah, this is what I find as network engineer, fellow network engineer. This is also the fun stuff. There's a real pain. Nobody wants to get woken up in the night for some stupid repetitive thing. This is where you start to develop real hate against some of your transit providers, right? And you understand exactly where all the submarine cables are because you get paged many, many different times. Anyways, just some examples. Yeah, if you're interested, come and talk to us. We are always hiring as well, and we'd love to chat more about network automation later. Thank you very much.